All right, people. I believe everybody is doing great, nice, and absolutely fine. Welcome to Unacademy NEET English. Let me know in the chats if I am audible and visible properly, if you can hear me. Let me know in the chats. Okay. Everybody out there, am I audible and visible properly? Okay. So we have this beautiful session today that is the top questions from electrostatics. Okay, we'll be solving some of the beautiful questions. When it comes to the theoretical part, I have shown you every category of problems. I have shown you all the, theory patterns in the game of NEET one shots, okay, in the marathon sessions. So over here in this one, we will be exactly talking about the best of the best questions which have the probability that these questions can be asked in your NEET exam in 2024. Let me know in the chats, guys. And if you have not liked the session, like it as soon as possible. Okay, that's mandatory. Like the session, mark the attendance. Everybody out there, let me know in the chats. Okay. Yes, JE students can also watch this particular session. JE students can also watch this particular session. Everybody, good morning, good morning, good morning. Okay. So I want all of you to basically focus over here. We'll get done with this particular session in just 1 hour or 1.5 hours. Okay. That will be the maximum duration. So good morning, good morning, good morning. I believe everybody is doing great, nice, and absolutely fine. And make sure you hit the like button. And afterwards, we'll be basically sharing this particular PDF or the notes in your Telegram channel. Okay. So join the Telegram channel as soon as possible. That is Unacademy NEET English. Okay. So people, I hope the Josh is high. I hope the Josh is high. Let's basically dive into this particular session. Let's start the session. Okay. That is, we say top 100 questions. Okay. Of electrostatics. Top 100 questions of electrostatics. Everybody out there. Okay. You know, guys, what is the rule? The rule is basically I'll be showing you the question on the screen, and before you guys have to solve this particular question. Read the question very carefully over here. Okay, I hope everything is visible properly. I'll be teaching you the optics also. Don't worry about that. That is the separate game of NEET. Okay, don't worry about that. I'll be teaching that also. So we have got the first question also. This was the previous year question. This was the question which was asked in AIPMT previously. This was the question which was asked in AIPMT previously. Okay. In this particular question, what we are given is that you can read the question over here. Two equal charged identical metal spheres A and B repel each other with a force F. Repel each other with a force F. Another identical uncharged sphere C is touched to A and then placed midway of A and B. You are supposed to tell me what is the net force on the sphere C. That is what we are supposed to say over here. Listen to me very carefully. I'll make you understand this particular question. Let's suppose what is mentioned in the question. First, let's understand this particular question over here. Okay. That is, we say it is given that two equal charged identical metal spheres. Okay, we have got two equally charged identical metal spheres. Let me make that over here. Let's suppose this is the first metal sphere. This is the first metal sphere, that is, let's suppose A. Okay, just a second. This is, we say over here, we have got, this is the metal sphere A. And then we have got another metal sphere over here. We have got another metal sphere over here. That is, we say we have got the metal sphere over here. That is B. This is the metal sphere B over here. How much is the charge on the metal sphere A? We say, sir, equally charged. We say, let's suppose Q, and on this metal sphere is also Q. Okay. This is the first statement which is mentioned in the question. Two equally charged metal spheres A and B repel each other with a force F. Now, let's suppose the distance between them is exactly given as R. Distance between them is exactly given as R. Okay. Listen to me very carefully. If this distance is given over here as R, Could you please tell me, sir, what is the force between the two? We say, sir, when it comes to the force between the two, force is equal to F is equal to K Q1 Q2 divided by R square. This is how we exactly calculate the force, okay? F is equal to K Q1 Q2 by R square. Now, my dear friends, I can directly write over here, this is K. What is the charge on the first sphere? That is Q. Charge on the second sphere, that is also Q. So I can say K Q square divided by R square over here. So this is, we say, the force over here, that is, let's suppose A, K Q square divided by R square. Okay. Now, let's basically read the second part of the question. It says that another identical uncharged sphere C, we have got the another identical uncharged sphere C, is touched with A. Now, we are bringing the another sphere, that is this one. This is the sphere C. And we are touching this sphere, we are touching this particular sphere C with the sphere A, okay? And this is uncharged. No charge is present on this particular sphere. And then it says that then placed at the midway of the A and B. What happens afterwards? We are placing this sphere at the midway. We are placing this sphere at the midway. Let me basically make it something like this. Let me copy paste it over here. So we are placing this particular sphere at the midway. So where is the midway? I'll just tell you. So take this particular sphere and place it over here. This is what we call, this is, we say, sir, this is the charge which is placed at the midway. Now, my dear friends, what is this distance? We say, sir, this distance is R by 2. And what is this distance between these two? We say, sir, this is also R by 2 over here. This distance is R by 2. This distance is R by 2. And what will be the charge right now? See, when you are touching this sphere C with the sphere A, sphere C has got 0 charge. And when you are touching the sphere C with the sphere A, means now the charge will be shared. On this, it will be Q by 2. On this sphere, it will be also Q by 2, because initially it was 0 on this one. Now, you have to tell me the net force on the sphere C and in the direction, in which direction. You have to tell me what is the net force, on this sphere C. Listen to me very carefully, I'll make you understand this particular thing over here. See, when it comes to the sphere C, on this sphere, we know, sir, this sphere A will apply the force. This is positively charged. We say, sir, on this force will be something like this. This is force on C due to, we say, A. Force on sphere C due to which sphere? Due to this A sphere. And this is also positively charged, that is B. Okay, B will also apply the force on sphere C. Okay, so we say that will be something like this. This is force on C due to B. I can say it something like this. Okay, now, my dear people, can we calculate this force over here? Can we calculate this force over here? Can we calculate this force over here? If I ask you to tell me what is the force on sphere C due to B, force on sphere C due to B, you will simply say, sir, that is K Q1. Q1 means this charge. This is the force between this sphere and this sphere. Q1, that is Q by 2. I can write it something like this, Q divided by 2. Okay. And then Q2, what is the charge on this? That is Q. Then it will be Q square and then divided by R square, and we can write R square by 4. It is simply K Q1 Q2 by R square. First is Q by 2. Second is Q divided by distance between them is R by 2. And we say R by 2 whole square. That will be R square divided by 4. I hope there is no confusion till over here. So I can simply write this over here. This will be simply 2 ones, 2 twos, and this will be 2 times of K. This will be Q square divided by R square. And we can say FC times of FCB. It will be simply, see, KQ square divided by R square. If you come till over here, if you go till over here, so you see KQ square by R square is F. So you can say this will be simply 2 times of F. Similarly, my dear friends, you can calculate this force over here. You can calculate this force over here. That is FCA. What is the FCA? FCA is the force between, we say, sir, this sphere and this sphere. That will be equal to, sir, K Q1. What is the value of Q1? That is Q by 2. What is the value of q2? That is q by 2. So that will be q divided by 2, and it will be exactly whole square. So I'll just write it something like this: k q square by 4, and this will be k q1 q2 by r square. Okay, and then it is something like this: k q by 2 into q by 2. That will be q square by 4. That's what I'm writing directly over here. So it will be simply, we say, sir, r square divided by 4. Okay, now this 4 and this 4 will cancel out over here, and this will be, sir, kq square by r. That will be f only. Now you guys are supposed to tell me what is the net force. See, guys, this FCB came out to be 2f, and this FCA came out to be f only. Now you tell me one thing: this is FCB, that is 2f, and this is, we say, sir, this is FCA, that is f only. Now you guys tell me one thing: what is the net force over here? Net force will be simply this force, larger force minus smaller force, that is 2f minus f, that will be f. And what will be the direction? Direction of this will be towards larger force, and that is this direction. We say towards a, f towards a. Now look at the options over here. This was one of the good questions over here. Option A is the correct option. Tell me in the chats, is this crystal and clear to each and everyone? Is this crystal and clear to each and everyone, guys? Let me know in the chats. Is this crystal and clear, guys? Is this crystal and clear? Is this crystal and clear? Everybody in the chats, guys. Let's move on to the next question we have over here. This is the next question we have on the screen. This is the next question we have on the screen. Okay. I hope everybody is able to understand each and every single question over here. I hope everybody is able to understand each and every single question over here. Okay. Great. Now, this question. So we have, in this particular case, we have a charge q, okay, plus q fixed at each of the 3 corners over here. So let me basically show you this particular question. In this question, what is given is that, see, let me just show you. We are given a square, okay? We are given a square, okay? This is the square that we are given. And on this one, we have got, on this corner, we have got plus q. On this corner, we have got this q. And on this corner, we have got plus q. On this corner, we have got plus q, okay? This part you will be basically reading at the end, okay? Or read it and understand the question over here. So we are given a square. In this, we have got plus q charge, and plus q charge, and then you have the q charge over here on the screen. Now, my dear friends, listen to me very carefully. Listen to me very carefully. In this case, the questioner is saying that we have got a charge plus q fixed at each of the corners. On the empty corner, a charge q is placed. Let's suppose this is the empty corner. On this empty corner, we say capital Q is placed, okay? And then such that there is no net force acting on diagonally opposite charge. Such that there is no net force. 0 is the net force on this diagonally opposite charge. Diagonally opposite charge to which one? Diagonally opposite charge to this one, okay? We have net force on this one is given as 0. Let's first find the force on this particular charge. Listen to me very carefully. If I say in this particular case, sir, on this one, we say the first force will act in this direction, because this charge will repel this charge. Let's suppose this is the F1 force. Similarly, we have the charge Q over here. This will also repel this charge in this direction. Let's say this is F2, okay? Now, my dear friends, let's call this as this is over here. Let's suppose this is A. This side is basically A. Now, sir, we have got this charge over here also. So this charge will also apply the force on this charge, something like this, because this is also positive, and we call this as F dash. Now, could you please tell me, sir, what is the net force on this particular charge? You say, sir, net force on this charge will be the resultant of this force and the resultant of this force. Resultant of F1 and resultant of F2. We have got the F1 over here. We have got the F2 over here. The resultant will be the net force over here and plus this one. Now, I can just write over here resultant of, we say, F1 and F2. My dear friends, we can clearly see over here, this F1 will be equal to the F2 force. Why? Why? Because you can clearly see in this particular case, because this Q1 and Q2 are same. Over here, this Q1 and this Q2 are also same, and distance between them is also same. So when the two forces are at 90 degree, could you please tell me what is the net force in that case? We say, sir, that will be a √2 of F. If I say F2 is F, F1 is F, the resultant is simply √2 of F. Yes, a lot of people are giving me the correct answer over here. Now, I can say in this case, sir, the resultant of this force and this force will be simply, I would say, along this one, that is under root of F. Now, could you please tell me what is the net force acting on this one? We say, sir, net force will be simply, that is under root of 2F plus, we say, sir, F dash. This is F dash. Now, in the question it says that net force on it is 0. So if I make it equal to 0, so I can simply say this is under root of 2F. What is the value of F? F means force between this one and this one, or this one and this one. That is KQ square. That is simply, we say, KQ square divided by A square, because distance between them is A. Then you have plus over here. F dash. F dash is which force? F dash is, we say, the force between this one and this one. Could you please tell me what is this distance? This distance, I can simply say this, that is √2A. Diagonal. So I can say this will be simply, I can say over here, that is K, this is Q, okay, and then this will be this Q. Okay, because one charge is small q, other charge is capital Q, divided by, we say, 2A square, because it is √2A whole square. That will be 2A square, and make it equal to 0. Now we can say √2KQ square divided by A square. This will be equal to minus KQQ divided by 2A square. You can write it something like this. So we say this and this will get cancelled out over here. Okay, and in this case, this and this will get cancelled out over here. K and K will get cancelled out over here, and Q will be simply in this case, this Q will be simply in this case, that is 2√2Q, and then put the negative also over here, minus 2√2Q. And which option is the correct option over here? Minus 2√2Q, option second. Is this clear? Is this clear to each and everyone? Tell me, guys, is this crystalline clear to each and everyone? Tell me in the chats, everybody out there. Is this clear? Is this clear? Yes, great. You have got the next question over here on the screen. I want you guys to basically focus on this particular question. Tell me the answer of this question over here. Tell me the answer of this question over here. See, in this particular question, what is given is that you have got plus Q, plus Q, plus Q, plus Q. Okay. This is basically, we say, pentagon, 5 sides. And at the center, you have got minus Q charge, and over here, there is no charge placed at this corner. You guys are supposed to tell me what is the net force at center. What is the net force at center on this particular charge? What is the net force on this charge which is placed at the center? What is the net force on the charge which is placed at the center in this case? See, could you please tell me? Tell me, what is the net force on the center? 0 cannot be the answer over here because there is no charge present. If I say the question is something like this, let's suppose I'll make it something like this. Let's suppose I will make it something like this. So I'm placing the charge over here. This is plus Q. In this case, you can say the net force at the center will be 0. But over here, sir, the charge is not present at this particular position. The charge is not present at this particular position. If the charge is not present, how can you say the net force at the center will be 0? See, let me just tell you how to solve this. If this, in this particular case, you can always say net force at the center is 0. Why, sir? Because this is a symmetrical figure. Similar charges are placed at the corners, so at the center we say net force will be 0. As simple as that. But in this question, we have got over here, this place is empty. We say no charge is present over here. Means, can I say at this particular place net charge is 0? Sir, net charge is 0. That also means you can say if you place plus Q over here and if you place minus Q over here, it is one and the same thing. Because plus Q minus Q, once again net charge will become 0. This is the trick how to solve this type of questions. So we say we can assume net charge is 0 over here. So once again we can say net charge in this case is 0. Why? Because plus Q minus Q. Either you say no charge or you can also say plus Q and minus Q. That is one and the same thing. Now, let me just tell you in this particular case, my dear people. Let me just tell you in this particular case. Guys, if I say you take a look on these particular charges, plus Q, plus Q, plus Q, plus Q, similar charges. Okay? Separate this minus Q over here. Can I say because of this plus Q, 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 because of all of these, sir, net force at the center will be 0. Yes, sir. Because why? We have studied. If you have got the similar charges on the corners, then net force in that case will be 0 at the center. Same is the case over here. Net force in this case will be 0 at center because of these. Now, what is the remaining charge? I can write over here because of plus Q charges, F net at center is 0. Yes, sir. Now, I can tell you over here, if because of these plus Q charges, net force at the center is 0. What is remaining? Remaining is this minus Q. So I can say, now, force is due to minus Q charge only. Minus Q charge only. Now, how much is that? Let's suppose this distance is A. Sir, the force on this one will be due to the minus Q, that is F is equal to, we say, sir, F is equal to, sir, K, Q, and then we have this Q divided by, we say, A square. This is the force at this, on this particular charge in this particular case. Let me know in the chats if this is crystal and clear to each and everyone. Let me know in the chats if this is crystal and clear to each and everyone. Tell me, guys, is this clear? Simply what you are supposed to do, you have to assume over here it is plus Q and minus Q. Because of the plus Q's, the charge is 0, then force is 0 at the center. So because of this minus Q, the force will be at the center. That is K, Q, Q, capital Q, small q divided by A square. Next question we have over here. This is the question on the vector form. Okay. Whenever you have to find the force, see guys, in this case, you are given the charge over here. Let me just show you. You are given the charge over here. That is, we say, sir, this one, this is the charge. And what is the magnitude of this charge over here? We say, sir, that is plus 2, minus 2Q. And we are given another charge over here. What is the magnitude of this charge? We say, sir, that is 4Q. You have got two charges in this particular case. This is 4Q and this one over here is, we say, sir, minus 2Q. This is the coordinates of this charge and these are the coordinates of this charge. Now in this question, it is asked that find the force on minus 2Q charge. You guys are supposed to tell me the force on minus 2Q charge. Which one? Force on this minus 2Q charge. You guys are supposed to tell me in this particular case. This is the question on vector form. Could you solve this particular question over here? Like this session if you have not liked this session yet, guys. Tell me in the chats, everybody. All the people out there. See. Now, let me just tell you in this particular case, listen to me very carefully. Listen to me very carefully. Sir, what is that? As if you have to find the force between the two charges, we know, sir, force is equal to K, then we have Q1, then we have, sir, Q2 divided by, we say, sir, R square. This is what we call the scalar form, or it gives the magnitude only. Magnitude only. Now, in this case, you have given the two charges, but in this case, you will have to use the vector form. You will have to use the vector form. What is the vector form of this force? F is equal to K, Q1, Q2 divided by R cube into R vector. So this is the Coulomb's law in vector form. And if you have to find the force between the two charges, its direction as well as magnitude, you will have to use this one. You will have to use this one. Okay. Now listen to me very carefully. Listen to me very carefully. I'll make you understand. Sir, first and the foremost thing over here, what is the value of K? K is 9 into 10 raised power 9. What is the value of Q1? In this case, Q1 is given as, we can clearly see, minus 2 Coulomb. Q2 is given as, sir, 4 Coulomb. And then distance between them is R. Now, how to find the R over here? R is not given. Listen to me very carefully. R means the distance between these two charges. How to find this R? You can say, sir, this will be simply, this R vector will be R2 minus R1. This position vector minus this position vector. Remember it directly. If you have to find the distance between this vector between the two charges, it will be R2 minus R1. Now, listen to me very carefully over here. My dear people, if you have to find this R over here, how do you find this R? What is the value of R2? The coordinates are given. This is in the vector form. Sir, this is R2. R2 means the R2 means this radius vector of this one. Okay, from the origin. How to find this? Write it directly. That is, coordinates are given. We say, sir, it will be simply, we say, sir, R2 means I cap plus, this one is basically I cap. This is 4j cap, plus, we say, sir, 3k cap. We say plus 3k cap in this one. If you have to, guys, what I'm trying to say, if you have to basically find the, we say, R1 vector, how do you write? Or R2 vector, how do you write? This is I cap plus j cap plus, we say, sir, k cap. Okay, 4j cap plus 4k cap. This will be R2 minus. Then you have to write R1. How do you write the R1 vector? Simply, we say, sir, that will be 5i cap plus 1j cap plus 3k cap. Simply, we can write it something like this. It will be, I'll write over here, that is 5i cap plus, we say, sir, 1j cap, that is j cap, plus, we say, sir, 3k cap in this case. Now, if you subtract this, see, I and you have 5i. So I can simply write, finally, this will be over here. I can simply write, this will be minus 4i cap, okay? Then you have, see, 4j cap and then minus j cap. That will 4 minus 1 is 3. So that will be over here 3j cap. Then we say plus 0 because this is plus 3 and then you have minus 3 over here. It will be 0. So this is the R vector. I hope you got it how to find the R vector. And now if you have to find the mod of R, magnitude of R, how do you write it? You say under root of, this is, we say, sir, 4 square plus, we say, sir, 3 square. This 4 square plus this 3 square, and this will be under root of 25 and this will come out to be 5 only. So this is the magnitude of this one. Now put all of these values in this force formula and then get the value of force over here. Now, my dear people, I can write over here, this force will be simply, sir, K. K is K. What is the value of Q1 over here? Value of Q1 means this charge. That is, we say, sir, minus 2 Coulomb, because this charge is given as minus 2 Coulomb. And value of this is given as 4 Coulomb. So I can write this is minus 2 and then we have 4, Q1, Q2. Divided by R cube. What is the value of R? The value of R is coming out to be 5. So we say, sir, 5 cube. And then you have to put the value of, this R vector. Could you please tell me what is the R vector? Sir, this is the R vector we have got. Okay, so I can write in this particular case, R vector is simply that is minus 4 I cap plus 3 j cap. Okay, so we can say in this particular case, we say, sir, this will be F is equal to, sir, 2 into 4 is minus 8k divided by 5 cube and then minus 4I plus 3j. You can keep it something like this only. Once in the NEET, the question was asked and you'll be given the option something like, you don't have to further solve it, just keep it like this only. Tell me in the chats. Tell me in the chats, is this crystalline clear? Is this question crystalline clear? Is this question crystalline clear to each and everyone over here? Tell me in the chats. Everybody, guys, is this question crystalline clear to each and everyone? And like this session if you have not liked the session. Do it as soon as possible. Great. Simply, if you have to find the force in a vector form, you'll be using this formula. First, you'll be finding the R vector. Then you will be finding basically this R cube mod of that. Okay. Now, this we have the next question over here. A particle of mass m carrying the charge minus q1 is moving around the charge, is moving around plus 2q. What is given in this particular question? Listen to me very carefully. We are given a charge, a particle of mass m carrying charge minus q1. We have the charge, we say, sir, minus q1 over here. And its mass is, we say, sir, m. Its mass is, we say, sir, m. Okay. Is moving around, we say, q2. Is moving around q2. Let me just show you something like this over here. So this particle, this q1 is actually moving. This particle q1 is actually moving around, we say, around. This q1 is actually moving something like this. Just a second. We have got a particle of q1 minus q1, its mass is m. It is moving around the charge plus 2q. We say, sir, plus q2, plus q2. Okay. Okay. I'll be showing you the questions on every chapter. Okay. First, let's finish the electrostatics first. Okay. And distance between them is, let's suppose this is basically r. And this charge is, let's suppose, moving with the velocity v. And what is, find the time period of the, we have to find if this charge q1 is rotating, revolving around this q2. We have to find the time period. Time period means in how much time it will complete one cycle. In how much time it will complete one cycle means if it is leaving from this point, in how much time it will complete this particular cycle. That is what we call the time period. That's what we call the time period over here. Now, my dear people, listen to me very carefully. I'll make you understand in this particular case. So, I have told you before. Here, if we have two charges, this one and this one, we say, sir, electrostatic force will act. Electrostatic force will act between the two charges. And since the two charges are in the circular motion, centripetal force will also act. So over here, we say electrostatic force, that is Fe, will be equal to the centripetal force, that is Fc. Electrostatic force is equal to the centripetal force in this particular case. So over here, we say centripetal force will be equal to the electrostatic force. And when it comes to the electrostatic force, we say, sir, K Q1 Q2 divided by R square. This is how do we find the electrostatic force. And centripetal force will be simply mv square divided by R. mv square divided by R. Okay. Now, one more formula you must know that from your mechanics, that is V is equal to R times of omega. Okay, sir, V is equal to R times of omega. Angular velocity, linear velocity. This is the relation between linear and angular velocity. Now, if you put it over here, you can simply write this is K Q1 Q2 divided by R square is equal to, then you have M. Instead of V, you can write R square omega square divided by R. This and this will get cancelled out over here. So what remains in this particular case is, we can say this is K Q1 Q2 divided by R square is equal to, we say, sir, M R omega square, mr omega square. Instead of this omega, my dear people, we know one more formula, that is omega is equal to 2 pi divided by, we say, t. Omega is equal to 2 pi divided by t. Okay. Now, if you put the value of omega is equal to 2 pi divided by t over here, if you put it over here instead of this omega, so you can simply write, this will be 2 pi divided by t and its whole square, because we have got the omega square. Okay. Now, in this particular case, my dear people, I want you guys to basically do one thing. So what is that? I say, you can simply say, take this mr over here. So this will be k q1 q2 divided by m, and then you say r into r will be r cube is equal to, we say, sir, 2 pi divided by t whole square. And if you take the square over here, it becomes the root. So you can say this time period will be simply, that is 2 pi. Okay, 2 pi. Then you have under root of, then you say m r cube divided by k q1 and q2. q1 and q2. Okay, just the reshuffling I am doing. This is the time period. So if a negative charge is revolving around the positive charge, how much will be the time period of that charge which is revolving? That will be simply t is equal to 2 pi mr cube divided by k q1 q2. Tell me in the chats if this is crystalline clear. Guys, you can get the notes from my Telegram channel, that is t.me/Yawar Manzoor. t.me/Yawar Manzoor. You can get the notes from this particular Telegram channel. I want you guys to join it as soon as possible and like this particular session as soon as possible. Is this clear? Tell me in the chats, guys. Is this clear? Is this clear to each and everyone over here? Okay, let's move on to the next question. Okay, this is the question in which we are given. So we say over here, the question says that we have got the two small spheres having a charge plus q, two small spheres having the charge plus q are suspended by insulating threads of length L. Okay, so it is something like this. We have got the two charges over here. So they are suspended. This is the first one and this is the second one. Okay, both are having the charge plus q, and in this particular case, let's suppose this is the angle theta over here, and the length of the string is, let's suppose, L. From a hook. The arrangement is taken in the space where there is no gravitational effect. Then the angle between the two threads and the tension will be, see. In this particular case, if I ask you to tell me, first let's suppose I ask you to tell me, find the tension in this case. See, if you have got the two charges, let's suppose this is plus q and let's suppose this is plus q. And over here, you have got this tension. Tension is in the string. Always, if you have a thread and you have a block connected to that thread, we say tension is there. Now, my dear friends, this type of question I have told you in the game of NEET. I have shown you every pattern. Over there, I told you how to find the tension in this particular case. Tell me one thing in this. What is that? We say, my dear people, I say in this particular case, what are the forces which are acting on this one? You say, sir, the forces acting on this charge, take any charge. In the downward direction, it is mg. And in this direction, it will be, sir, that is electrostatic force, because you have the charge q1, you have the charge q2. Between them is electrostatic force, and that is Fe. This is the electrostatic force, Fe. Okay. And Next thing I just want to tell you over here, I can say that is simply, we say, sir, if this is t, one of its components along this will be, we say, sir, if this is theta, this will be t cos of theta, and this component will be, sir, t sine of theta. Now, over here, I can clearly say this is in the equilibrium. Okay, let's suppose this is in the equilibrium over here. My dear people, I say this force will be equal to this force. This force will be equal to this force. Tell me one thing in this particular case. If I say over here, if I say mg is equal to 0, there is no gravitational force in this particular case. See, if there is no gravitational force acting on this particular charge, listen to me very carefully, means the force which is pulling it in the downward direction is 0. So what is going to happen in this particular case? We say, sir, this electrostatic force which is acting in this direction, it will basically pull it something like this. And afterwards, if I just make the figure over here, the figure will be something like this. The figure will be something like this. You have got this charge, you have got this charge. Okay, the two charges. Okay, and in this particular case, this is the electrostatic force acting, and this will be the tension. Sir, it will be something like this. The two forces will look something like this. Okay, why? Because the mg downward force is 0. If mg was there, then it would have been something like this. We say in this case, downward force is, we say, 0. Can we say in this particular case, if the downward force is 0, no force is acting in the downward direction. So we say, sir, this force, tension, will be simply equal to this force. Right side force is equal to the left side force. So we say in this particular case, tension is equal to the electrostatic force. And when it comes to, let's suppose this is plus Q, and the length of the string is L. This is also L. Okay, because this length is given as L. So means this will be L and this will be also L. Now tell me, what is the electrostatic force over here? Sir, K, Q1 is Q, Q2 is also Q, that is Q square divided by distance between them, that is 2L. We say, sir, 2L, and this will be whole square. This is simply the electrostatic force which will act over here. And what is the value of theta in this particular case? You say, sir, theta in this particular case is 90 degrees. Tell me in the chats, is this clear, guys? I am saying if mg was present over here, then it would have placed, then this charge would have been over here. If I say mg is not there, downward force is not acting, so what will happen? This force will elongate. It will. These two forces will go, and it will be something like this. And in that case, we say electrostatic force will be equal to the tension. Is this clear? I just need to know. In the live chat over here. Okay, so when mg is equal to 0, in that case, this angle would become 90 degrees. Over here. Yes, mg is equal to 0 is mentioned in the question. See, there is no gravitational effect. Gravitational effect means mg is equal to 0, because we have taken this entire system to the space. Okay, great. Let's move on to the next question. You have got the next question over here. We have got the two small conducting spheres, each of mass. This one are suspended by from the same point of this sphere. Non-conducting strings. The length is 100 centimeter. Okay. Let me just tell you. In this particular question, what is given is that we have got something like this. We have got a charge. This is the first charge, and we have got the next charge over here. Okay, the two charges are basically connected this is a thread we have, this is a string we have, and we have connected the two charges over here. Okay, now in this particular case, this is a charge q1 over here given. Okay, let's call this as charge q. The two charges, each of mass, this one, two small conducting spheres, okay, of mass, this one, are suspended at the same point. Okay, two, let's suppose these are the two spheres, and the mass of the spheres is, let's suppose, m, and this is also the charge q over here. Mass on this sphere is also q. Okay, now my dear people, in this particular case, we say this angle is mentioned over here, that is 45 degrees. This angle is mentioned 45 degrees, and the length, this length is given as, we say, sir, 1 meters over here. Okay, and this is the distance between the two, that is, we say, sir, r. This is the distance between the two, that is r. Now my dear people, tell me one thing over here. What is that? Could you please tell me what are the forces acting on this particular charge? We say, sir, in the downward direction, we say, sir, mg is acting. In this direction, we say, sir, electrostatic force is acting, k q1 q2 by r square. And this is, we say, sir, tension. And this is which component? We say, sir, t cos of theta. And this is which component? We say, sir, t sine of theta. Okay. And clearly we say in this particular case, sir, t sine of theta is equal to electrostatic force. Okay, this, if the charge is in the equilibrium, means this force is equal to this force. Okay, and we can say t cos of theta in this case is equal to simply, sir, mg. This force t cos of theta is equal to, sir, this force, that is mg. Now if you divide the two, t sine theta by t cos theta, t will get cancel, and it will be tan of theta is equal to, what is the value of electrostatic force? K q1 q2 by r square. And I can write over here, this will be simply k, q1 is q, q2 is also q, k q square divided by r square, and then you have mg over here. Okay, now my dear friends, can you tell me the value of this q? You can say, sir, the value of this q will be simply, listen to me very carefully, it will be, sir, q square. It will be, you say, sir, this will be mg, then you have tan of theta, then you have r square. Take this mg r square over there, it will be mg tan theta into r square divided by, we say, k, divided by, we say, sir, this k. Okay, now if you want to find the value of q over here, this q will be simply, take the square over there, it will become root, so it will be under root of, we say, sir, mg, then you have tan of theta. Okay, then you have divided by k multiplied by, we say, r. Now put the values. Once you put the values, the answer will come out to be, in this case, option A. This is what we were supposed to find in this particular question. We have got the two small conducting spheres of mass. Mass is basically 9 into 10 raised power minus 4 kgs, suspended from a small point, of length of string is 100 centimeters. Okay, and we are giving, in this case, theta is also given 45 degrees, and you are supposed to tell me in this case how much is the charge on each sphere. The charge on each sphere is over here, that we got. Tell me in the chats, is this crystalline clear? Is this crystalline clear? If you have watched my electrostatics marathon, every question, every pattern of question I have shown over there, and these patterns I have also shown over there. And if in a question you are asked to find the value of r, this distance between the two charges, this also I have shown over there, and you can find this r from this particular thing, and you have to basically get this r. But in that case, q will be given from there only. Is this clear? Is this clear? Now this is a question which was asked in, we say, sir, JEE mains 2022. This is the question from JEE mains. Is this clear? Come on. Length you can find, my dear friend, over here. This r, if you have to find this r, you can find, take this triangle, tan of theta, That will be this perpendicular divided by this length base. Okay, that's why I told you this is homework. Some calculations you'll do from your end only, na? Guys, can you solve this particular question? You guys are supposed to tell me what is the net electric field at this particular point O. These are the 4 options I am giving. This is the first. Look at the diagram first. And these are the 4 options which are given over here. Tell me, which option is correct? A, B, C, D. Which option is correct over here? A, B, C, D. This is a very good question. And I want you guys to basically solve this particular question. Tell me. This is the figure. This is the figure we have. A, B, C, D. Which option? Which option? Let me just show you in this particular case. See. Let's suppose over here, if we have a charge Q at r distance, how much is the electric field, sir? K Q divided by r square. This we know. If you have the charge Q at r distance, the electric field is KQ divided by r square. Okay. Now, my dear people, listen to me very carefully. If you have this particular point over here, and I want you guys to tell me the electric field at this particular point because of this charge, because of all the charges. First of all, let's find the electric field at this particular point because of this charge Q. We say, sir, because of this charge Q, electric field will be something like this. Let's call that electric field E1. Okay, this is the electric field and this distance is given as L. Okay, electric field because of this charge is away from the charge because charge is positive. So it will be, sir, E1. Can you tell me the value of E1 over here? Sir, the value of E1 will be simply, sir, K Q divided by R square. At what distance? We say, sir, L square. Let's call this as E. KQ divided by E square. Now, could you please tell me the electric field because of this charge now? Sir, because of this charge at the center, this would be the electric field. Let's call this as E2. Okay, let's call this as E2. And this E2 in this case will be simply, we say, sir, it will be simply, that is K. What is the charge given? Charge is over here, that is mine 2Q. So I can simply say, sir, that is 2Q divided by, we say, sir, L square. Okay, and this is 2 times of KQ by L square. So it will be simply, we can call this as 2E. Now, my dear friends, let me just tell you E. What is the value of electric field over here because of this one, because of this charge, because of this 2Q? Can we say because of this 2Q also? Let me just mark it over here, something like this only. Sir, we got this electric field, as E. This is, we say, sir, 2E. And could you please tell me what is the electric field because of this charge at this particular point? We say, sir, that would be something like this. And that will be how much? We say, sir, charge is 2Q, length is L. So that will be 2E also. As simple as that. Because KQ divided by L square, that is 2E. Okay. Now, what is the electric field because of this charge at this particular point? Charge is E only. So at this particular point, we say, sir, electric field will be E only. Okay. Is this clear? Now, my dear friends, tell me one thing. Sir, because of this, could you please tell me what is the electric field because of this charge at this center? You say, sir, electric field would be something like this. Let's say, why it is towards the charge? Because charge is negative. Let's call this as E. And electric field because of this upper charge, which is at this top corner, that will be also E. Okay. Now, tell me one thing over here. Sir, electric field because of this charge. Okay. Electric field because of this charge. Okay. I can say that will be simply something like this. And how much that will be? Right, let's write that over here. Let's call that electric field E3. How much that will be? See. That will be KQ. What is the value of Q over here? That is Q only. That is KQ divided by, what is the distance? Distance from this charge till center, that is root 2L. That will be root 2L and its whole square. So I can say this will be simply that is KQ by 2L square, that is E divided by 2, you can call it. Because KQ by L square is E, so it will be E by 2. So we can say this will be simply E divided by 2. This will be simply E divided by 2. Yes. Now, because of this charge, because of this 2Q, what will be the electric field at the center? That will be something like this. How much is that? Let's find. Sir, it will be E4. So that will be how much? Sir, K 2Q divided by, we say, root 2L, and it will be whole square. And this will be simply E. This will be E. Because this is 2 at the top in the numerator, 2 in the denominator, 2 will get cancelled. It will be KQ by L square. That will be E only. So this electric field will be E. This is one of the best questions in this particular session. Now, my dear people, these are the electric fields and you have to find the resultant in this case. Tell me one thing. Sir, this electric field will get cancelled with this electric field because they are equal and opposite. Okay, done. Now, this electric field and this electric field, could you please tell me the resultant? I'll make it over here. See, resultant of 2A and E. Sir, 2E minus E will be E, and that will be in the downward direction. I'll make it something like this. This will be E. In the downward direction. Now, my dear friends, this and this is also sorted. Tell me, sir, resultant of this one and this one, that is 2E and E, that will be 2E minus E will be E only, and that will be simply in this direction. This is E, because the larger one is in this direction. So this one and this one is sorted. Now, which one are remaining? This one, and we have got this one. It is E by 2 and E. Now, this one, E minus E by 2 will be E only, and E by 2 only. So that will be in this direction. So this will be E by 2. This will be E by 2. This will be E by 2. Okay. Now, guys, you have got this E. You have got this E. What is the resultant of E and E? Because angle is 90 degrees over here. That will be root 2E. And this will be the resultant of this one and this one. That is root 2E. Okay, now in this particular case, you can say, sir, E net will be simply, you have got root 2E, you have got E by 2. So you can say, sir, root 2E minus, we say, sir, E divided by 2. And in this case, you can say E, you will take common. This is root 2 minus 1 by 2. Option B is the correct option. Option B is the correct option. Is this clear and crystal and clear? Tell me in the chats, guys. Is this crystal and clear? Is this crystal and clear? Is this crystal and clear? Everybody out there? Because sometimes you should follow good questions also. Sometimes there has to be the good pattern of questions also, which has the chances that these questions should come in the NEET. Because tomorrow, if you'll go into the exam, guys, over there, if you'll see the easy type of questions, you'll be solving that within the seconds. Because you have practiced the best, we say the next level questions in the practice sessions. Is this clear? Okay, great. Now tell me over here. One more question I'll give you over here. The question is basically, you have got 2 microcoulomb charge over here. You have got 2 microcoulomb charge, and you have got 8 microcoulomb charge over here. You have got 2 microcoulomb charge over here, and you have got 8 microcoulomb charge over here. Okay. Now, in this particular case, you guys are supposed to tell me, find the position. I'll write over here. Find the position. Find the position. Find the position. Find the position where Find the position where net electric field is 0. I hope you remember, I have told you in case of the forces. We have got the one charge, we have got another charge, then we were placing the third charge. Where should we place the third charge so that net force on the third charge is 0? Same is the question over here. We have to find the position where net electric field is 0. Same formula we will be using over here also. See guys, this charge is positive, this charge is positive. Over there I told you, sir, over there I told you, we say, my dear people, listen to me very carefully. We say, sir, we say, in this case, this x will be equal to r upon under root of n plus 1. Under root of n plus 1. The position where net electric field is 0 is which one? X. And how to find that x? R upon under root of n plus 1. R is given 12 over here. If you have to find that position over here, my dear people, if I say, listen to me very carefully. You have got this plus 2q. You have got this plus 2 microcoulomb, 8 microcoulomb. Let's suppose at this particular point, because of 2 microcoulomb, this is the electric, this is the force, this is the electric field. Because of the 8 microcoulomb, this is the electric field. Can we say the electric field is opposite? So we can say net electric field is 0. So what is the value of this x? You have to find the value of this x. What is the position over here? We say, let me just tell you. See guys, first of all, what is r over here? R is given as 12 upon under root of. What is n? How to find n? We say, sir, n is, listen to me very carefully. N is how many times this is greater than this one. So how to find n? Take this 8, divide it with the 2. So we say 8 divided by 2, that will come out to be 4. So we say n in this case is 4 under root of 4 plus 1. So it will be 12 upon root 4 is, we say 2, 2 plus 1 is 3. So we say 12 divided by 3, that is 4. So in this particular case, we say, sir, at 4 centimeters, net electric field will be 0. At 4 centimeters, net electric field will be 0. Tell me, in this particular question, you have got 2 microcoulomb charge. You have got 2 microcoulomb charge over here, this one, and you have got 36 microcoulomb charge. You have got, sorry, 25 microcoulomb charge. You have got 36 microcoulomb charge, and distance between them is 11. You guys are supposed to tell me, find the position where net electric field is 0. Find the position where net electric field is 0. I'll be uploading the notes in the Telegram channel, okay? Find the position where net electric field is 0. Find the position where net electric field is equal to 0. Tell me, everybody out there, find the position where net electric field is 0. Find the position where net electric field is 0. See, sir, in this case also, if we have to find the position, find that position where net electric field is 0, how to find x is equal to r upon under root of, we say, sir, n plus 1. Now, how to find the value of n over here? We say, sir, n will be simply, we say this charge, this one, 36 one, it is how many times greater than this one? How to find? That will be 36 divided by, we say, sir, 25. 36 divided by 25 will get the value of n. Now, put it over here. We say, sir, x is equal to r upon under root of n. What is the value of n? That is 36 divided by 25 plus, we say, sir, 1. 36 divided by 25 plus, we say, 1. Now, what is the value of r? That is 11 over here. Okay, the value of r is 11 over here. So divided by, we say, 36. Root 36 is how much? That is 6. That is 6 divided by root 25 is how much? That is 5. Okay, plus, we say, sir, 1. Now, in this case, you can say this is 11 upon 5 into 1 is 5. 5 plus 6 is 11 divided by, we say, sir, 5. And this will come out to be 5 centimeter. Okay, and this will be 5 centimeter from smaller charge. And smaller charge is which one? Smaller charge is 25 microcoulomb. So from 25 microcoulomb, it is at net electric field will be 0 at what distance? We say, sir, 5 centimeter. So at this point, net is equal to 0. Guys, tell me in the chats, everybody, is this crystalline clear? Are you liking this particular session? If you are liking the session, then make sure you hit the like button. If you are liking the session, then make sure you hit the like button. This is the question. This was asked in JEE mains. This is a very good question you have over here. Yes, 6 centimeter from the larger charge. You can say it something like that also. Now, read the question very carefully and answer this particular question over here. Tell me the answer of this particular question. Read the question and answer it. Tell me, a thin copper ring of radius A is charged with Q units of electricity. Okay. An electron is placed at the center of the copper ring. If the electron is displaced little, it will have frequency. It will have frequency. See, let me just tell you over here. We have got a ring. Okay. On this ring, the charge plus Q is present. This is the charge which is present on the entire ring. And the radius of the ring is, we say, sir, capital R. Radius of the ring is, we say, sir, capital R. Radius of the ring, we say the capital R. Now, my dear friends, we say in this particular case, if we have an electron which is present at the center, Let's suppose the electron is over here. We have the electron which is present at the center. And we are displacing that electron. Electron has got negative charge. This ring has got positive charge. Means if you displace the ring, if you displace the electron from the ring, we say this positively charged ring will attract that electron towards itself. So if you displace the electron something like this is the electron, negative charge. Now the ring will attract it towards the positive, towards itself, and when it comes towards the ring, at the center, it will not stop, it will go over here. Again, the ring will attract it towards itself. Again, it will go, it will not stop over here because it has got the velocity or kinetic energy. It will go over here. So it will basically start the kind of oscillations over here. And if it starts the oscillation, it will have the frequency. You have to find the frequency of that oscillation. Yes, you will have to find the frequency of that oscillation. Can you tell me the answer of this particular question over here? If you have got a charge, okay, this is a negative charge, you displaced it from the center and then it will start oscillating. You have to find the frequency of that oscillation over here. First and the foremost thing, in order to find the frequency, let's first find the force on the charge. Listen to me very carefully. Let's find the force acting on the charge, on the electron. My dear people, when it comes to the force, we say, sir, force is equal to Q times of E. You have got the charge and multiplied by the electric field, you will get the force. Now the point is, sir, what is the electric field if the charge is present over here? Sir, electric field will be because of the ring. Now we know, sir, electric field because of the ring is simply, everybody knows it, that is K, Q, X. X is the distance, Q is the charge on the ring, divided by, we say, sir, R square plus X square whole raised power 3 by 2. This is the electric field produced because of the ring at this point. And at this point only we have placed the charge. Now electric field we got. How to find the force? It will be, sir, we say, sir, instead of electric field we write K, Q, X. And then you have this charge also, this small q. Write it over here. Upon, we say, sir, R square plus X square whole raised power 3 by 2. And in this case, it is saying that in the question, electron is displaced little. Means this displacement is very small. Means X is much less than R. this x is much less than r. R is the radius of the ring. So if x is much less than r, we can basically neglect the x over here. So the force will come out to be, we say, sir, kq. Then you have x. Then you have this small q upon, we say, sir, this will be r cube only in the denominator. Okay. Now, my dear people, this is the force that you have got. Now, from the SHM, we have studied one equation. I'll write over here from the SHM. From the SHM, we have studied one equation. Sir, what is that? That is acceleration is equal to minus omega square of x. Acceleration of a particle which is performing SHM is this one. If there is a particle which is performing the oscillations SHM, it is basically, we say, its acceleration is, because in the numerator we do not cancel this x. This is, I have told you many times in the classes, that if you have got, let's suppose we say r square plus x square. If you have got, this is a very small quantity, this is a very large quantity. If you add a very small quantity to a very large quantity, we say it is nothing is gonna happen over there. It will not create any difference. It is like you are adding a bucket of water to the ocean. Will it create any difference? No. That's why we say in the numerator, in the denominator, we cancel it. In the numerator, we do not neglect it. If you neglect it in the numerator, the entire term will get cancelled over there. Okay. Now we say acceleration is minus omega square of x. Acceleration is minus omega square of x. Now, my dear friends, we say when it comes to the acceleration, just we say, sir, acceleration is f divided by m. And what is the force? Force is this much. So you say, sir, k q x divided by q. Okay. This is divided by r square. Okay. R cube. This is the force. Force divided by mass, multiply the mass over here. So it will be basically, this is the acceleration, because acceleration is f by m. Now is equal to, we say, sir, omega square of x. Neglect this negative sign, because the negative sign tells us the force is always opposite to displacement, just the direction. Neglect it. So we say this x and this x will get cancelled over here. So omega will come out to be under root of, we say simply, that is k q, this q divided by, we say, mr cube. This is the omega. Now, my dear people, in this particular case, listen to me very carefully. There is one more formula for omega. That is omega is equal to 2 pi into f. Okay, omega is equal to 2 pi into f. F means the frequency. Now, my dear people, we say over here, I can write this is 2 pi f is equal to under root of, we say, sir, k q, this q divided by mr cube. I can write it something like this. Now further, I can write f is equal to, you can simply say 1 upon 2 pi. This will be under root of, you can say, sir, this will be q, and this charge small q is basically, this is actually the electron which is displaced. So the charge on an electron is E upon, and instead of this k, can we write it is 1 by 4 pi epsilon naught? Yes, sir. So I'll write it over here. Let me take the whole term. It will be 1 by 4 pi epsilon naught QE divided by m r cube. R is given as over here A, because the radius is given as over here, A. Okay, this will be the frequency. Because in the question it is given as, so which one is 1 by 4 pi epsilon naught QE divided by MA cube. 1 by 4 pi epsilon naught QE divided by MA cube. 1 by 4 pi QE 4 pi epsilon naught E by MA cube. This one, option 2. Option 2 is, I guess, matching. 1 by 2 pi upon 1 by 4 pi epsilon naught Q by Q into E. Q into, no, not this one. 1 by 4 pi epsilon naught. This one is matching. Option 1 is matching. Is this clear, guys? Tell me in the chats. Each and everyone, guys. Let me know if this is crystalline clear to each and everyone. Is this clear? Enough. Now, in this case, you guys are supposed to tell me, find the flux. Find the flux through the plate. Find the flux through the plate. You have got the charge over here. This is the charge placed over here at the top of the plate. And you have to tell me the flux through this particular plate over here. Okay. This is the question. This I'll give you the homework. Okay. The next question over here. Now, in this particular case, we have a rod. Okay. We have a rod. This rod is placed inside the box, inside the cube. And you guys are supposed to tell me how much is the flux through this cube. How much is the flux through this cube? Guys, like this session if you have not liked. So you guys are supposed to tell me how much is the flux through this entire cube over here. Okay. Listen to me very carefully. From the Gauss law, we have studied that if you have got a closed surface, and in that closed surface you have got a charge, flux will be through that closed surface is simply Q inside divided by epsilon naught. So flux through that closed surface is simply Q inside divided by epsilon naught. This is the flux through a closed surface. Okay. As simple as that. This is the flux through a closed surface. Now, my dear friends, if you have to find the flux through this closed surface over here, you will simply say, sir, flux through this closed surface will be, that is Q inside divided by epsilon naught. Now, in this case, we don't know how much is the charge inside, but the charge per unit length is given. Lambda is given over here. How to find the charge in this case? Listen to me very carefully. If I say, sir, when it comes to the lambda, charge per unit length, we say, sir, charge per unit length is simply, that is Q divided by, we say in this case, sir, if I just talk about how much is the length of this side, that is A. And if you have to find the charge in this one, see, you have placed the rod something like this. The rod which is in the A distance. See, let's suppose entire rod has got a large amount of charge, but the rod which is present inside only will have to take that charge only. So we say in this case, the rod which is present in A distance, A length, we have to take that length only. So we say the charge which is inside, that is Q in. So I'll just write over here, this is Q in. Okay, Q in divided by, we say, sir, Q in charge upon, we say, sir, charge per unit length. Length is A. Okay, so lambda is charge per unit length, Q divided by A. So we say Q in this case will be lambda into A. Now put this lambda into A over here in this equation. So we can say flux in this case will be, that is lambda into A divided by epsilon. Is this clear, guys? Okay, is this clear? Tell me. Now, can you solve this particular question we have over here? Find the flux in the sphere. So we say the flux will be only because of this much of the rod. Flux will be only because of this much of the rod, because this much is only inside the sphere. This radius is given as R. This will be R by 2. Now, my dear friends, if I say in this particular case, take a look over here. Can you tell me if we join this one, this will be also R, because this is the radius? If this is R by 2, this is, we say, sir, R. Could you please tell me this? Let's suppose this is X. Could you please tell me this distance, this length? You say, sir, X in this case is under root of, we say simply X in this case is under root of, that will be R square plus R by 2 whole square. Okay, see, you know this one, you have to find this one in this particular case. Huh? Tell me, is this clear? Is this clear? Okay, and then you can find the value of x in this case. See, by using this you can find the value of x in this case. See, you can find the value of this x. Once you get the value of this x in this case, then multiply it with the another x. This is also x, and this will be also x. X plus x is 2x. So means this much is the length of the rod which is present inside. And once you get this length, once you get this charge which is present inside, okay, once you get this one which is present inside, then, my dear friends, you can find the flux. Flux will be simply, that is Q inside divided by epsilon naught. This also I will give you the homework over here, because you have to apply the same concept which I have used over here. Sir, Q inside divided by epsilon naught. In this case, Q inside, how did you find it? Lambda into A. A was the length present inside, length of the rod present inside the cube. Over here, how much is the length which is present inside? That is x plus x is 2x. First get the value of x, then multiply that x with the lambda, you'll get the charge inside, and then put up over here, you'll get the value of this one. Okay. Now, could you please tell me, this was the question asked in JEE 2010. What is the flux through this particular phase? What is the flux through this particular phase? This phase, ABCD. What is the net flux through ABCD phase? We know if we have a charge inside a cube, if we have a charge inside a closed surface, it will create flux. Okay. Now, in this case, if we say this charge Q, it is at L by 2 distance from this particular phase. Similarly, we say this charge which is outside, it is also at the same distance. It is also at the same distance from this particular phase. Now, my dear friends, in this case, we say, sir, this will create the flux over here. This will create the flux over here. Sir, this will also, because of this one, listen to me very carefully. Because of this charge, the flux through this phase will be something like this. This will be the flux through this phase. This is because of this charge. Similarly, if we take a look over here, because of this charge also, the flux will be there. The flux will be there. The flux will be there. Okay. See, flux because of this charge will be this one. Flux because of this charge will be something like this. We know, sir, flux because of this will be something like this also. Something like this also. We know that. Whenever there is a charge, we say it will create flux. Now, my dear friends, in this case, the flux which is crossing this one because of this charge is exactly equal to the flux because of this charge which is crossing opposite to this one. So, in this case, we say net flux through ABCD is equal to 0. Flux through this will be 0. If you ask me what is the flux because of this charge only through the entire cube, that will be Q by epsilon naught. But when we talk about this phase particularly, we say because of this flux will be something. Because of this also flux will be something. So net flux in that case will be 0. Net flux we are talking about this particular phase ABCD. Is this clear? Is this clear? Now we have the next question which was asked in IIT JEE Advanced 2014. This was the question asked IIT JEE 2014 Advanced. Listen to me very carefully. We are given the solid spheres over here. We are given the solid spheres over here. See, we have this solid sphere. We have this solid sphere. And we have this solid sphere. Okay. And when it comes to this first solid sphere, the radius of the solid sphere is r by 2. It's a smaller one. And the radius of this sphere is capital R. And when it comes to radius of this sphere, it is, we say, sir, 2r. We say it is 2r. Now, my dear friends, we are taking a point A which is at r distance, We have to find the electric field in this case at r distance. Okay. we have to find the electric field at this point P. In this case also, we have to find the electric field at point P. In this case also, we have to find the electric field at point P. Now, when it comes to this one, sir, the point P is at r distance and r distance will lie outside this particular sphere. And in this case, r distance will lie at the surface. And in this case, r distance will lie inside. Why? Because this is a bigger sphere. Now, let's talk about the electric field because of the first sphere. Electric field because of the first sphere. Listen to me very carefully. Sir, electric field because of first sphere, let's suppose that is E1. How to find that? How to find that? We say, sir, E1 is equal to KQ divided by, we say, sir, R square. Sir, how much is the charge on this sphere? That is Q. At what distance you have to find the electric field? That is R. So that's why we say electric field outside the solid sphere is KQ by R square. Okay. And we say this is outside point. Outside point. Let's talk about the electric field because of the second sphere at point P. Now, this is the second sphere. This is the second sphere. When it comes to the second sphere, the point P is the surface. The point P is the surface. So we say electric field because of the solid sphere on the surface is also KQ divided by, we say, sir, R square. Now the question in this case is, we say, sir, over here charge on the sphere is 2Q. So I'll write over here instead of Q, I'll write over here it will be 2Q. So we say this is the surface point. Surface point. Okay. Now let's talk about the electric field because of the third sphere. Electric field because of this third sphere. So when it comes to this one, this is the third sphere. Electric field at point P, which is the inside point. So we have studied electric field because of a solid sphere inside. Electric field because of a solid sphere inside. Remember this formula. We say, sir, electric field because of a solid sphere inside is KQ divided by R cube into R. KQ divided by R cube into R. This is the electric field because of a solid sphere inside. Inside. Where R is the radius of that solid sphere, capital R. And this R is the distance at which you are finding the electric field inside. Okay. So if I just write it over here, I can write this will be K. And when it comes to the Q, charge on this is, we say, sir, charge on this is, we say, sir, 4Q. So we say this is 4Q divided by radius. What is the radius of this bigger sphere? That is 2R and it will be whole cube. And multiplied by at what distance you are finding it at small r, at small r is equal to capital R over here. So we say this will be R. So we can further write it. This is K and this will be 4Q divided by, we say this will be 8R square. And further if we solve it, it will be KQ. It will be KQ divided by, we say 2R square. KQ divided by 2R square. Now, if you compare this E3, this E3 electric field with E2 electric field and with E1 electric field, you can clearly see that. E2 is the greater electric field. Then we say E1, then we say E2, then we say E3. Because E3 is KQ divided by 2R square. This is KQ divided by 2KQ by R square. And this is, so we can clearly say in this case, electric field second is greater than electric field at first. It's greater than electric field in case of third. Is this clear, guys? Is this clear, guys? Tell me, is this clear, guys? Which one? In E2, R is equal to R by 2. No. In this case, in E2, guys, in E2, we say this is the radius and This is the point P. Point P will lie on the surface in this case. So R, this is correct. E1. Sir, E1 will be 4kq by R square. How it will be 4kq by R square? See, you are finding the electric field outside. Electric field outside will be kq divided by R square. This R you have to take. Guys, this is the... Have you not studied the marathons? You were not present in the marathon session. If you have got a solid sphere, let me just tell you, the radius of the solid sphere is R. This is the point which is outside point, let's suppose small r. This is the point which is inside point, let's call this also as small r, because small r is variable. Now if I say electric field outside is kq divided by small r square. Electric field surface is kq divided by capital R square, because on surface small r is equal to capital R. Now in this case small r is equal to capital R only, because that lies outside. Is this clear now? That's why I took over here capital R square. Is this clear? If you are confused, how does this exactly come? I recommend you guys to watch the one shot. I request you guys to watch the Electrostatics marathon, which is Game of NEET by Yawar sir. You can watch that and you'll get to understand the each and every single thing. Okay. Now in this case, you guys are supposed to tell me, the electric field of the sphere at 20 centimeter is E. The electric field of the sphere at 20 centimeter is E. Find the electric field at 5 centimeters. Okay. Electric field at 20 centimeter is E. You guys are supposed to tell me the electric field at 5 centimeter. Electric field inside. This is electric field outside. See, in this case, electric field outside is given as, we say, sir, kq divided by R square. This is the electric field outside the sphere. And this will be simply, that is kq divided by, what is the radius outside, distance outside? That is 20. So we say, sir, this is 20 square. Okay. Now, when we talk about the inside, so we say, sir, inside electric field, it is different. So what is that? E is equal to kqr. E is equal to kqr. E is equal to kqr divided by, we say, sir, r cube. Now, in this case, we say, sir, E is equal to, this is kq. What is the value of r? R is the radius. That is 10 over here. This is 10 divided by capital R in this case. Capital R in this case. Sorry. I made a mistake. Capital R means radius. This electric field inside, this is the small r. So that is 5. And then we have 10 cube over here. This is inside. Now, my dear friends, if we have to find the ratio, so if we have to find the ratio over here, what will we do? We say, sir, E divided by E naught will be simply. E divided by E naught will be simply. E naught is the electric field inside. This is the electric field inside. And E is the electric field outside. So I can simply say, if you divide this with this one, okay, equation first with equation second, this is the E naught. So what you will get over here is, see, this kq will get cancelled with this kq. So what remains over here is, we say, sir, it remains, that is 10, and this will be cube divided by, we say, 20 cube into 5. Solve it, it will come out to be 1 by 2. If you do the ratio, this will come out to be 1 by 2 in this case. Okay. Now, in this case, if you have to find this E naught will be simply 2 times of E. Okay. Directly. See, what I exactly did is that you have got a sphere. Because of the sphere, electric field outside at 20 centimeters outside, electric field is given as E. And we have to find electric field inside at 5 centimeters. Radius of the sphere is given as 10 centimeter. Now, electric field outside, if you have to find, that is this one. This is outside. Okay, that is kq divided by 20 square. And if you find the inside we know the formula is k cube into r divided by capital R cube. Now, small r means at what distance you are finding the electric field inside. That is 5 centimeter. That is given as this 5 centimeter. And capital R means a radius over here. That is, we say 10 centimeter. And outside small r is this one, inside small r is this one. Keep this thing in your mind. So then I got the value. Then I divide this electric field with this electric field. And I got the ratio equal to 1 by 2. And then I got finally this one. Is this clear? Is this clear, guys? Is this clear? This is your homework I am giving. You have got a dipole. See, this is the homework I am giving over here. You have got a dipole over here. Okay. And you are supposed to tell me, because of the dipole, what is the electric field at A, what is the electric field at B. Because of the dipole, electric field at B and electric field at A. Let me show you this particular question. Let me show you this particular question over here. See, listen to me very carefully. If you have got the dipole over here, this is the dipole, okay? Because of this dipole, you have to find the electric field at point B. And you have to find the electric field at point A. Tell me one thing. I have told you when it comes to the point A is the general point. Okay? In case of this particular dipole, point A is the general point. Sir, what is point B? Point B is the actual point. Sir, point B lies on the axis of this particular dipole. And if I talk about this point is the perpendicular bisector point. This point is the general point. This is the actual point. Now, we know the formula when it comes to the general point. The formula for electric field is, we say, sir, Kp divided by R cube or X cube. Then we say under root of 3 cos square of theta plus 1. 3 cos square of theta plus 1. Okay, this is the electric field because of a dipole at general point. Now we say electric field at this general point is, sir, Kp divided by X. Tell me one thing. Sir, if we talk about this point, X means in that case, R means in that case, this is root 2 into L. For general point, from this dipole, this R is basically root 2 into L. So I can say, I can write over here, this is root 2, okay, into, we say, sir, L, and this will be whole cube. This will be R in that case. Now, my dear people, tell me over here, I say this is under root of 3 cos square of theta. What is theta given over here? That is 45 degrees. So I can say 3 cos square of 45 plus, we say, 1. Okay. And what is the value of cos 45? We say, sir, 1 by root 2 in that case. So I can write, this will be EA is equal. So we say this will be Kp divided by root 2 into L whole cube. And then you have under root of 3 by 2. And then we have plus 1 in this case. Now, my dear people, what I can write over here, this will be simply electric field EA is equal to, sir, this is 3 by 2 plus 1. This 3 by 2 plus 1 will be 5 by 2. So it will be under root of, we say, 5 divided by 2. And then you have Kp divided by, you say, a root 2L whole cube. Okay. Now you have root 2 whole cube, means root 2 3 times. And then you have this root 2. So finally the answer would come out to be root 5 divided by 4 Kp divided by L cube. Okay. Now, in order to find the electric, this is the electric field at general point. Now to find the electric field, at point B. If we find the electric field at point B, which is the actual point, and in case of axes, we say, sir, electric field at B will be, the formula for axis is simply 2kp divided by r cube. 2kp divided by r cube. And in this case, we say, sir, this will be simply 2kp divided by, we say, L cube. What is P? P is the dipole moment. This is the electric field at B, and this is the electric field at A. This one, this is the electric field at A. Is this clear? Tell me in the chats, is this clear? Tell me in the chats, guys. Tell me in the chats. Now, this question we have over here. I want you guys to tell me the answer of this particular question. You have got two dipoles. This is the first dipole you have over here, and this one is the next dipole you have over here. This one, and we say, sir, this one. Okay. Now you have to tell me, you have to tell me the electric field at this point. Electric field at this point because of the two dipoles. Because of this dipole and because of this dipole. Now, listen to me very carefully. This was the question which was asked in J Mains 2021. Guys, because of when it comes to this dipole, this point is the actual point for this particular dipole. This point is the actual point for this dipole. Okay. Now, listen to me very carefully. When it comes to the actual point, we say over here, electric field because of this dipole at this particular point is something like this. This is the electric field. E is equal to, we say, 2kp divided by x cube. We know, sir, because of the dipole, electric field at a point is, we say, at the axis is 2kp by x cube. And when it comes to this dipole, because of this dipole, electric field at this point is, we say this will be the perpendicular bisector, and that will be something like this. And this electric field will be simply, sir, kp divided by x cube. Okay, kp divided by x cube. Now, my dear friends, this is, we say this is the electric field over here. Okay, this is the electric field over here. And we say the net resultant of these will be something like this. This is the electric field which is resultant. Okay. And how do we find the resultant in this case? See, this is the electric field because of this dipole. And this one is the electric field because of this dipole. How to find the resultant in this case? We say, sir, ER will be simply, that is under root of this one plus, we say, this one. So that will be 2kp divided by x cube, and this is whole square, plus, we say, kp divided by x cube, its whole square. Okay, this one. Now, in this particular case, if you solve this, it will come out to be simply, that is kp divided by, we say, x cube, and this is the root of 5. kp by x cube under root 5. This is the answer. Now, this is the question which was asked in NEET 2022. This is the homework I am giving you. This is simple. And this is the another good question which I am giving you. This is also the homework. I want you guys to answer all of these questions. I want all of you guys to basically answer these questions in the comments. And guys, let me know. This was all about it. Okay. Thank you so much for today's session. And let me know in the comment section how was the session. Okay. So thank you for today's session. So this was all about it. See you guys in the next session. So we say this was all about it. So thank you so much. Take care and bye-bye. And let me know in the comments how was the session, each and everything. Okay. So take care and bye bye. This was all about it, and you'll get the mm, this in Telegram. Okay, you'll get the PDF in the Telegram. Okay, guys. So thank you so much.